Modern physics does not exclude the fact that the universe in which we live is not the only one. Therefore, just in case, scientists agreed to write the word universe with an uppercase letter when it comes to our spacetime, and with a lowercase letter in other cases. According to cosmologists, the universe was formed almost 14 billion years ago as a result of a large explosion of an infinitely small volume of highly concentrated matter. Since then, it has been constantly expanding at a rate equal to the Hubble constant, and this is one of the fundamental physical parameters, based on the volume of all visible and invisible material that can be detected in any way. Today, the length of the universe from edge to edge is about 93 billion light-years. What lies beyond this limit? Some scientists call infinite nothingness. Others believe that spacetime closes on itself, forming a hypersphere. This is indicated, in particular, by deviations in the cosmic microwave background, the relic electromagnetic radiation that arose about 375,000 years after the Big Bang, when the first atoms were formed. At the same time, researchers agree that the universe used to be much smaller, and theoretically, by tracking its evolution in the opposite direction, it is possible to reach the point of the Big Bang, when everything arose from nothing. According to the generally accepted theory of cosmology, the universe was formed from a singularity, when matter and energy were compressed into one point. In the first fractions of a second of the Big Bang, during a period called inflation, the cosmos swelled to enormous proportions. What happened before the singularity? The theory does not explain. Besides, there is no physical and mathematical description of this state itself. Scientists who adhere to the cyclic model believe that our universe was preceded by some other one, perhaps similar to ours, but evolved in the opposite direction. Over time, it shrank to a point, and there was a big explosion. The conformal cyclic model assumes that our universe is just one of the stages in the life of a multiple universe that goes through an infinite number of cycles. During each of them, it cools and expands until the masses of all its material particles decrease to zero. The duration of the cycle is trillions of years. The inflationary model proposed in 1981 by the American scientist Alan Guth suggests that during the physical expansion at the early stage of the Big Bang, a network of universes was formed, similar to interconnected soap bubbles. We live inside one of them, with no way to see what's going on in the others. That is, in a parallel world. What are parallel worlds from a scientific point of view? A parallel world is a hypothetical concept that assumes the existence of other realities or dimensions that coexist with our world, but are in some way separate from it. In such worlds, different laws of nature apply, and their inhabitants and events differ from what we observe in our own reality. Assumptions about parallel worlds arise within various fields of science and philosophy, such as physics, quantum mechanics, metaphysics, and theories of multiple universes. At the moment, there is no direct empirical evidence for the existence of parallel worlds, the idea of which is mainly based on theoretical assumptions and mathematical models. The famous English theoretical physicist, astrophysicist, director of scientific work at the Centre for Cosmology at the University of Cambridge, Stephen Hawking, believed that black holes are portals to parallel worlds, and the famous relict spot in the constellation Eridanus may well be an imprint from another reality. Parallel universes, or worlds that hypothetically exist simultaneously with our world, do not necessarily resemble it. There are suggestions that completely different laws of nature operate there, and all events take different, and even directly opposite outcomes. If in our world a coin tossed up fell heads up, then in another reality it fell tails. The first scientist to suggest the existence of such parallel realities was the Austrian physicist Erwin Schrödinger. In 1952, he gave a lecture on quantum mechanics in Dublin and introduced the concept of superposition, or a phenomenon in which a particle can simultaneously be in several completely different states. Later, science fiction writers began to use the idea of parallel worlds. One of the first books on this topic is Michael Moorcock's novel Split Worlds, 1963. To understand whether parallel worlds or universes can actually exist, we will look at some basic theories of modern physics. In 1983, physicists James Hartle and Stephen Hawking published a scientific article on a new theory of the origin of our universe. With the help of quantum mechanics, scientists have tried to explain how the world could have appeared out of nothing and what happened before the earliest epoch and the earliest stage in the development of our universe. Stephen Hawking is an English theoretical physicist, cosmologist, and astrophysicist. He devoted most of his scientific career to cosmology, a branch of astronomy that studies the appearance and evolution of the universe. In addition to scientific works, he has published several books on the subject: A Brief History of Time, Black Holes and Young Universes, and The World in a Nutshell. According to the theory of Hartle and Hawking, initially our entire world was in a state characterized by infinitely high density and temperature of matter. After the Big Bang, the universe expanded, forming galaxies, stars, and planets. Our universe still continues to expand infinitely. Describing the world around us, they have always considered our universe as a quantum system that can simultaneously be in an infinite number of states. Our reality is just one of these states. In addition to all this, there are parallel worlds that display all possible outcomes of any events that took place in the universe. In 1970, physicists Holger Nielsen and Leonard Susskind independently suggested that some elementary particles may not be point-like, but in the form of thin extended strands, the so-called quantum strings. According to the well-known theory of relativity, the universe includes 4 dimensions: length, width, depth, and time. According to string theory, there can be more measurements, from 6 to 26. However, we are only able to be aware of 4 of them. The rest of the dimensions collapse, and parallel universes can be placed in them. The first ideas of multiverse or parallel worlds arose in the 19th century from multidimensional geometry, according to which if there are more than 3 dimensions in space, then there may be several parallel or intersecting hyperplanes, in each of which the usual rules of 3-dimensional physics apply. The main sources of the idea of parallel worlds and the multiverse in modern science are the general theory of relativity and quantum theory. According to the theory of relativity, the geometry of spacetime, manifested in the form of gravitational fields, changes with time and interacts with matter. Therefore, a black hole can be a gateway to a parallel world. It is acceptable that so-called 3-dimensional brains from the word membrane live in multidimensional space, and parallel universes are located on their surface. It is possible to modify the theory of relativity so that space evolves and gives rise to virtually unrelated areas in which the laws of physics will differ significantly. In quantum physics, there is a measurement theory for closed systems, in which a problem arose due to the fact that instead of measuring the state of a quantum particle, one had to consider measuring or the state of the arrow of the device itself or even the experimenter. In 1957, the American scientist Hugh Everett noticed that the theory of measurements can be excluded from quantum mechanics, but then it turns out that in each of the experiments all possible outcomes are realized simultaneously. This led to the conclusion that the universe branches into numerous variants, and everything that could happen in principle happens in them. In each such parallel world there are very different, including directly opposite versions of the outcome of certain possible events. Thus, the multivariance of any event manifests itself not only in our imagination, but also in reality, in the form of possible outcomes of these events in different parallel worlds of our universe.